Hello again from Digicool Things. In a couple of recent videos, I covered the beginnings of my hexadecimal keypad design journey, when I presented the history of the project and then building and testing my initial tactile switch based budget Hex Keypad design. The tactile switch version Hex Keypad turned out quite nice and is significantly more usable than the cheap membrane keypads that are now generally available. Also noting that my keypad implements the standard key spacing, something you don't normally get with small membrane keypads. Having designed this initial Hex keypad, I then decided I'd also like to go further and design my ultimate version. The idea being to perhaps even improve on the comfort level that I recall I had when using my original mechanical Hex keypad back in the 70s and 80s. Also providing design flexibility so that the keyboard can be assembled in different ways depending on the intended application. Obviously, the best key switch choice for an ultimate keypad these days is to utilise Cherry MX key switches. So I designed an updated keypad PCB for a Cherry MX key based hexadecimal keypad. So here is the schematic. And here is the PCB layout. The new design also allows the optional use of Keyswitch Diodes, if desired, to allow avoiding key ghosting when multiple keys are simultaneously pressed. If this is required, you just need to insert 1N4148 diodes into the MX key switches. If not required, then I have provided solder bridge jumpers on the PCB to allow circumventing the diode option. Opening an MX key switch is very easy when you have the right tool. This is a 3D printed MX key switch opener. See if we can get it in focus. So let's give it a try. Here's a Cherry MX key switch and a diode. The MX key switch has two latches on each side, which you can probably just make out. So if we put those over the opener and just push down, the top of the switch will just pop off. There's a cavity in the front of the switch. See if we can see that a bit closer. There's a cavity right there in the front of the switch, which is designed to take either a diode or an LED. That's why there's 4 holes at the bottom. 2 holes wider apart are for a diode, and the 2 holes closer together are for an LED if you had a transparent switch. For our purposes, we're just going to drop in a diode. As you can see, I've bent the legs to the appropriate shape. So I'll just take the switch off the opener and I can drop the diode through its mounting holes. I'll just push it in place with a screwdriver. And then I can put the switch back together again. Making sure I've got the cap round the right way. Then, as you can see, we now have 2 extra pins in our key switch for the 2 diode legs. Note that whether you choose to use diodes in your keypad matrix also depends on your application and the polling method used to read the keyboard matrix. For example, to implement a diode-protected keyboard matrix, assuming your input port pins are all pulled high, the polling algorithm needs to pull each row output low one at a time and detect any depressed keys by identifying any column inputs being pulled low for that active row. The diodes effectively blocking any key ghosting occurring from multiple simultaneous key presses across the matrix. The Dream 6800 computer, which started me on this journey, as I explained in my first Hex Keypad video, however will not work with the diodes fitted. The Dream 6800 chip-OS ROM uses a clever approach of having all matrix rows pulled low simultaneously, and then simply waits for any column to be pulled low via a key press. When a low column is detected, the polling algorithm then reverses the keyboard port directions so that all matrix columns are now pulled low, so that the activated row can then be determined. This approach is quite efficient, but reversing the keyboard matrix column row direction is not compatible with a diode-protected switch matrix. In order to complete my ultimate version keypad design, my next challenge was organising appropriate MX keycaps, which had the appropriate hexadecimal keypad legends. Readily available keyboard keycaps can provide for the A to F letters, but the numeric keys are generally designed for either the top row of a QWERTY keyboard, with punctuation symbols above the numbers, or for numeric keypads with additional arrow symbols. Neither of these numeric keycaps are desired. In fact, what we desire is simply just the symbols 0 to 9 and A to F, consistently sized and centered on each keycap. We also want consistent legends for the additional reset and function keys. So firstly, I located some MX keycaps with clip-on transparent caps, which allowed printed legend sheets to be cut out and inserted under the clip-on caps. This provided what initially seemed a viable solution, but I wasn't particularly happy with the need to insert and align printed legends, and also the clip-on keycap style didn't provide the desired MX keycap look and feel. Next, I did some further research on the common MX keycap profiles. I arrived at the uniformly shaped XDA profile as being the most appropriate for a retro hexadecimal keypad. So next I ordered some blank XDA profile MX keycaps and set myself up with a laser engraver with the intent of using a low-powered engraver to burn black ink into the blank keycaps to make the desired key legends. Some experimentation, including designing and making a jig to ensure consistent location of keycaps in the engraver, showed that this approach held the promise of being successful. Here's an example of one of the keycaps I was experimenting with. There are multiple legends as I was offsetting the legend so I could experiment 4 times on each keycap. But there were a couple of problems with this approach. Firstly, making each keycap legend in the laser engraver was relatively labour intensive, involving applying some black marker, then completing multiple passes in the low power laser engraver, and finally cleaning off the surplus marker ink to leave just the burned in symbol. Secondly, without some longer term testing, I had no idea how robust the laser burnt legends would be, with the typical wear and tear of fingers on the keyboard over a longer period of time. This is where my ultimate keypad design project stalled. That was a couple of years ago. Then recently I revisited the project, inspired by a couple of things. Firstly, I had since updated my 3D printer to a new Bamboo Labs X1C with AMS, which was giving me some really good quality 3D print results, a level up from my previous 3D printer. Secondly, I noticed some better than expected 3D printed keycap designs for a Commodore 64 keyboard that somebody had published on Thingiverse. On test printing one of these keycaps at a fine layer height, I was surprised by the resulting 3D printed keycap quality. Here's the test print I did. Possibly a bit hard to see on the video. But that's an A key from a Commodore 64 with the graphics characters on the front of the key, printed in white. Definitely a significant step up from when I last tried to 3D print an MX Keycap, just a couple of years ago. Secondly, my Bamboo Lab X1C came with an AMS that allows easy multicolour printing. So I had the idea of trying a two-colour print to allow embedded legends in a different colour in the printed MX keycaps. Inspired by this, I dived into creating my own XDA profile keycap models from scratch using Fusion 360. I then created embedded text legends in the keycap models and used Bamboo Studio to colour fill the legends with a different colour filament. After numerous tweaks to perfect the result, I have to say that I'm actually quite blown away with the final result, exceeding my previous expectations of what's actually achievable with an FDM 3D printer. So let's clear this out of the way, and here's a set of keycaps fresh off the printer. Now the camera probably doesn't really do them justice, but I can tell you, looking at them firsthand, I'm really impressed with the quality. I'll try and show you one a bit closer up and move it around a bit. You can see it's come out really nice. Here's the underside. There was even a bit of tweaking to get the mount perfected. So here's an assembled ultimate version of my Hexadecimal Keypad. Let's fit these keycaps. Notice these are also using the black MX key switches. Is it fully assembled? I think you'll agree, it looks great. And you can see the textured finish of the plastic from my PI print bed on my 3D printer. Makes a really nice finish. So there you see the original Tactile Switch budget version of the keyboard and the nice MX key switch. ultimate version of my keypad. Now, initially I created the keycaps in white with black legends, but in my desire to perfect the retro look of the keypad, I searched for the best retro beige colour I could find. And now I also have retro beige keycaps, the same black embedded legends. Here's what the retro beige coloured keycaps look like. I think they look great and also have a more retro look than the pristine white keys. Also, after careful consideration, I chose the Cherry MX brown key switches as the most appropriate match for a retro Hex Keypad. These are the non-clicky tactile feedback style of MX key switch. Finally, note that the design flexibility of using cherry key switches for the Hex Keypad also extends to the keypad layout. As we are using keycaps, we can choose how we want the hexadecimal matrix to be laid out. For example, we could choose to assign the keycaps in the 0 to F order from the upper left, or you could instead use an F to 0 order. Or you might even prefer a numeric phone keypad layout with the A to F keys around the edge. You simply choose how you fit the keycaps, depending on your preference or the application. The perfectionist in me is now happy enough with the result. I'm going to also add this ultimate Hex Keypad to my Tindie store in kitset form, for anybody who would also like a cherry key switch based hexadecimal keypad for the retro computer project. The kit set will include all the parts to make the completed keyboard you see, including the full set of dual coloured 3D printed keycaps and 3D printed key switch mounting plate. And also the optional 16 1N4148 diodes, so you can choose whether or not you want to insert these into the supplied Cherry MX key switches. Also the pin headers and the PCB standoffs to complete the keypad. In addition, I'm including the 3D printed key switch opener that I demonstrated earlier to make installing the diodes easy, if you choose to use them. Finally, there's the choice of whether you want the white or the retro beige coloured keycaps. Or alternatively, you can choose a bundle with both sets of keycap colours. So let's see how easy it is to assemble the kit set. So to start off, I've laid out all the components of the kit set. First, I'll solder in the pin headers. So I take the pin header strip and I need an 8-pin header for the hexadecimal matrix. 2, 3, 4, 5, 6, 7, 8. And a 3-pin header for the reset and function keys. So let's get them soldered in. Okay, the headers are soldered in and they look good. So then you'd fit the diodes in the key switches if you were taking the diode option, as I demonstrated earlier. I'm not using the diodes, so instead I'll solder bridge the diode jumpers on the PCB for each of the 16 hex key switches. Note the reset and function keys have pre-linked jumpers, as you normally wouldn't use diodes with these switches, as they're not part of the matrix. But I included pre-linked jumpers just in case you wanted to cut them open and use diodes on these two switches. So let's get the diode jumpers solder bridged. Okay, that completes the soldering. We have the headers in place and the diode jumpers all shorted. Next, I fit the Cherry MX key switches to the mounting plate. So these just push through from the top and clip into place. Now with the Cherry MX key switches all clipped into the mounting plate, we just need to check that all the key switch pins are nice and straight. Any that are bent, probably from your fingers, you just need to straighten them. With all the pins straight, the PCB should just drop in place. We can then solder all the key switches to the PCB. Then, with the soldering now finally complete, I'm going to fit the 4 PCB standoffs. And finally, I fit the keycaps in the arrangement that I want. So they just need to be pushed in place. And the job's done. And the Cherry MX brown key switches feel really nice. So there's our finished retro beige coloured keys, and here's the keypad I made up earlier with the white keys in a different layout. I hope you enjoyed my hexadecimal keypad journey. If you have an application for your own Hex Keypad and you'd like to support me, then please feel free to visit my Tindie store. A link is in the description. That's it. Thanks for watching.